Recommended testing tools, thermal imaging. The amount of radiation emitted by a steam trap increases with temperature. Therefore, thermography allows one to see variations in temperature. When viewed through a thermal imaging camera, a failed open trap may become easier to detect. Visual observations. Although limited in its scope, visual observation is an important first step in determining whether a steam trap is operating as designed. For example, certain visual signs, such as a lack of any condensate discharge or extremely large quantities of steam leaking out of a trap, may indicate the need for trap repair. This type of visual is limited to open condensate return systems dumping to the ground. Traps can also be externally inspected for pinhole, connection point, or gasket leaks. Verify the steam traps are installed correctly. Float-in thermostatic and inverted bucket steam traps should be installed plumb. In most cases, unless a condition problem can be clearly determined visually, testing traps by ultrasound and thermography will be necessary to provide a correct diagnosis. Testing using temperatures. Measuring the trap's inlet steam temperature is the first step in the process of testing for steam trap failure. The temperature at the trap's inlet should be near its saturated steam temperature. In some cases, such as subcooled or superheated steam, the temperature will be lower or higher than its saturated steam temperature. Temperature can be extremely useful when trying to determine if a trap is blocked or its condensate capacity is insufficient. This is because condensate backs up and lowers the trap's temperature. If the temperature is significantly lower than the saturated temperature and the application is in service, the lower reading generally indicates an undersized trap, incorrect pressure orifice for the trap, a blocked trap strainer, or possibly a negative differential condition, stall, in the case of equipment being supplied through a modulating control valve. In a stall condition, the trap may be in good condition, but an alternative drainage method is required. Replacing the trap in kind will have no effect on improving the drainage capability. Testing using ultrasound. Knowing the type of steam trap installed and how it operates is a critical part of accurate steam trap testing. An experienced steam trap surveyor using an ultrasonic probe, as described, should have an accuracy of 95%. Touching the probe upstream of the steam trap, about 12 inches or so, will get a sound baseline. Note the decibel reading on the indicator. Next, touch the probe downstream of the steam trap at the trap's outlet and observe the intensity levels and sound patterns. A decibel increase of 10 plus typically indicates a problem. A typical on-off trap should have a pattern of close, discharge, close. Listen for a tight shutoff. If the sound heard is a continuous rushing sound, it is most likely stuck open and wasting steam. A typical continuous trap should have a modulation pattern. If the sound heard is a continuous rushing sound, it is most likely stuck open and wasting steam.